Yenny, you press again to record, start record.
Oh, okay. Okay.
Okay. Okay. When I finish my class only, you stop the recording. Okay. So we will start today's lesson. Okay. I hope yesterday the homework you can do. Okay. So we continue for today. Okay. Simplify algebraic expression using the law. Okay. This is your index for today. Simplifying algebraic expressions. Okay. Today is 19. Okay, this one same thing. This one we're going to apply the logarithms laws yesterday, the 3 laws that we have learned. Okay, so look at this example 27. Okay, the A. Okay, express the following as a single logarithm. Okay, so you see this. Okay, so first of all, I'm going to drag this 3 up, become the power. Okay, and then log and the log same base. Okay, so I'm going to combine it. Okay, this one plus, so I'm going to combine it, become single log, it will become times log. Okay, so first step, move up the power, so this one will become y to power 3. Okay, and then plus will become times. Okay, make it become single log. Okay, so it's x times y to power 3. Okay, so A is very simple. Okay, now we look at B. Okay, B also same thing. First of all, the 2 and the half here are going to move up as a power. Okay, then after that, here in between is a minus. So when I combine it, becomes single log. It will be you have to use a divide. Okay, make sure it's a same base log A. Okay, so this is the answer you get. Okay, x squared divided by the y power half. Okay, y power half actually is a square root of y. Okay, okay, so become a x squared over square root of y. Okay, become single log. Okay, next C. Okay, C, the question is here. Okay, this is the questions. Okay, this one log 3. Okay, base 3. This one first step I'm going to move up. Okay, as a power, but I have this. Okay, the 1 here. Okay, a number here. Okay, so remember log 3 is 1. Okay, I want to make all this become a log, so change this 1 become log 3. If let's say here is 2, so it will become 2 log 3. Then exact same as exact others. If this is 5, then will be 5 log 3, and then move up as the power. Okay, so but this is 1, so it's only log 3. Okay, then you see this is a 3 logs. Okay, you want to combine it, become 1 log. Okay, so same thing. You have a plus and minus. So when you have a plus, it will be times, and then when you have minus, then this is divide. Okay, so it's x squared times y divided by 3. Okay, when you combine, become our single log. Okay, so this is example 27. Okay, now we go to example 28. Okay, for example 28. Okay, if P is a log B2, Q is B, write the following in terms of the P, Q, and K. So means same like that day, you have to try to relate this number, okay, with 2, 3, and 5. Okay, try to modify. Okay, try to adjust. Okay, maybe it's a factor, maybe okay, so that you can make use of this 2, 3, and 5 over here. Okay, so look at A. A is quite simple. 6 is 2 times 3. Okay, 6 is 2 times 3. Then you can, this one is times, so break it into 2 logs, so it become plus. Okay, so it will become log B2 plus log B3. Okay, log B2 is what? Okay, it's given here as P. So you replace this with P. Log B3 as Q. So you replace this as Q. So your final answer is P plus Q. Okay, next we go to log 45. Okay, 45 is, you can can write it as 9 times 5. Okay, 5 is here, but the 9 here, you got to adjust a little bit. You have a 3 here. So you can write it as a 3 to power 2. Okay. Then here, same thing. Here times, so here is plus. Okay, 3 to power 2, the 2 can drag in front. Okay, the 2, the power 2 drag in front, power law. Okay, so 2 is here. So log B3, okay, given is Q. So it is 2 times Q plus log B5 is R. So it becomes 2Q plus R. Okay, so this is the answer. Okay, look at C. C, they need you to use the previous knowledge that you know. Okay, the infinite repeated decimal. Okay, the recurring decimal. Okay, so you look at this side. Okay, if you want this one, you can copy that down. I like this example actually. Okay, so first of all, the 0.22222 you got to convert into 2 over 9. Okay, for those I already forgot how to convert. Okay, you will see this. Okay, first of all, you write 0.2222 as A or as N or whatever lah, and unknown. Okay, then after that, okay, is it I can times 10? Is it enough? 2. Is it times enough? I think times 10, is it the same thing? Okay, if this is A, 10A will be times 10 will be 2.222. Okay, after that, minus 10A minus 1A, so it's 9A. Then 2.2222 minus 0.222, that is 2. So A is 2 over 9. Same thing. Okay, so times 10 actually is enough already. Okay, no need to times 100. Okay, so you replace the 0.2222 with 2 over 9. Okay, then you will continue. Okay, check and see the 2 and the 9. Is it in the list given? Okay, 2 is here. Okay, 9 is, you can write it as a 3 to power of 2. Okay, so 9 over, 2 over 9, okay, become 2 logs. Okay, it's in between is minus. Okay, so 2 minus log B2 minus log B9. Okay, the 9, you write it as a 3 to power 2. Then the 2, the power, move it in front. Okay, then this is what you have. Okay, then log B2 replace with a P, log B3 replace with a Q. Okay, so this is the answer. Okay, last one. Okay, this is the last one. Okay, 5 and then square root of 3. This one means 5 times square root of 3 divided by 2. Okay, break it into 3 logs. So here is times. Okay, so here is plus. Here is divide. Then here is minus. Okay, so 5 is in the list. Okay, square root of 3 is a power half. So the power half, the half you move it in front. Okay, and then this one also is in the list. Okay, so replace the log B5 with R. Okay, log B3 with a Q, and then log B2 with the P. Okay, so this is the example 28. So this one will be your homework. Okay, next, you want to see this, okay, chain base, Okay, this one you can copy as your notes. Okay, if A, B, and the C are positive number, then A cannot be 1 and C cannot be 1. Okay, because the base cannot take 1 here. Okay, so log AB is equal to log CB over log CA. Okay, so you see, now I'm going to change the base A to base C. Okay, and then you remember this one will go to the numerator, and then the base here will become at the denominator. Okay, this is how I remember it lah. Okay, now we want to prove it. Same thing, this proof, I want you to copy. Okay, in case, okay, they ask in the question, ask you to prove this law. Okay, to prove the above statement are as follow. Okay, so first of all, you fix this log a b is x. Okay, the left hand side one, log a b, yeah, log a b as x. Okay, then how to say, this is a logarithmic form. Okay, change it into a index form. Okay, so b stay. Okay, a come to this side, become the base, and then x become the power. Okay, so this is how you get a to power x is equal to b. Okay, next, from here itself, this one, you log both sides. Okay, but now using log c. Okay, c as a base. Okay, so log c a to power x equals to log c b. Okay, this is the next step. Okay, next, the x here bring down. Okay, power law, the x here bring down. Okay, so this is, okay, the application of the power law. Okay, next, the x stay here because this is times. This term move to the right hand side. Okay, become divide. Okay, so this is what you get. Okay, then we come back to the first line. Okay, what you assume to. Okay, so what is x? What is x? X is the log AB. So replace the x with log AB. Therefore, you see, log AB is equal to log CB over log CA. This is how you get these equations or the formula. This is one more. Okay, this one you can copy. Okay, if B is equal to C, okay, B is equal to C, okay, then this C all replaced with B. Okay, the C here all replaced with B. Okay, then you will see this one become a log BB. Okay, and then log BA. Log BB is 1. Okay, so another one you can use is log AB is equal to 1 over log BA. Okay, means this one interchange. This one interchange. Log AB. Okay, then it will be 1 over, okay, become the at the denominator become a log BA. Okay. Okay, next we look at this. By using the law of base change, any logarithmic base can be written and erased base base 10 or base e. Okay, why base 10 and why base e? Because your calculator you can only press for base 10 and base e. Okay, wait, I call out the calculator. Okay, so you see your this log here is the base 10. Okay, and then this ln here is the base e. Okay, what is base e? For you will be a new things. Okay, logarithm with a base e are known as natural logarithms. Okay, and are written as a log base e or ln. This one we read it as ln. Okay, base E is often using in mathematics, science, and technology. Okay, actually you don't have to be scared with the E. Okay, why? E is just a number. You still remember beginning of the topic when we learn the rational number. Okay, E is just a number. Okay, a non-recurring decimal. Okay, 2.7182 blah 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 blah. It seems like pi. Pi is a 3.142 blah 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 blah. Okay, it's a non-recurring decimal. Okay, so why we only can use these two is because the calculator can press for these two. Okay, so when you want to change the base and then you want to use the calculator to get the answer, is either you change to base 10, if not you change to base E. Okay, so we continue to look at the example. Okay, determine the following value by changing their base to 10. Okay, so this one they want you to change the base to 10. Okay, so you see very simple. Okay, log 30 and then 4. So change the base to base 10. Okay, So the 4 put at the denominator, and then the 30 put at the denominator. Okay, so log become log 4 over log 30. Okay, if you want to write, you can write in this way. Okay? Remember log 10, you can write LG. Okay, short form of it now, LG. Okay, so you press log 4. Okay, then divide by log 10. Sorry, log 30. Okay,
Teacher,
so this is the answer. Why Why different? Yes.
What is the index?
What's the what?
Index.
What's the index?
Uh,
For today?
yeah.
Beginning, just now I say, simplifying algebraic expression. Okay or not?
Okay.
Beginning of the lesson, I say already. Okay, why I cannot get the answer? Okay, you see, I didn't close bracket here. I think so because of my mistake. Okay, so I do again. Okay, log 4 close bracket. Okay, and then divide by log 30 close bracket. Now only I get the answer. Okay, so please be careful. Here you got the close bracket. Okay, look at B the same thing. Okay, use log 10. Okay, so 0.45 as the numerator, 2 as the denominator. Okay, so this one you can do log 0.45 over log 2. Okay, so log 0.45 close bracket divide by log 2. Okay, so this is the answer. Okay, we go to another example. Okay, this one, example 30. Convert each of the following to a natural logarithms and evaluate them. Okay, so now just now they change to base 10. Now they want you to change to base e. Okay, so log e 254. This one as the numerator, this one as the denominator. Okay, so now how to use a calculator? Okay, ln okay, ln. Okay, so you can write as ln 254 over ln 6. Okay. Okay, so ln 254. Okay, close bracket divide by ln 6. Okay, close bracket. Okay, then this is the answer. Okay, B the same thing. Okay, so it's a ln 4 over ln 30. Okay, so ln 4 close bracket divide by the ln 30. Okay, this one. Okay. So these are the steps for using calculator. Okay, before I continue for this example 31, we come back to this previous page. Okay, this one, I want you to go through one by one for this. Okay, this one. Okay, ln A. This is not in A. This is a ln A. Okay, means log EA with the E as an exponent base. Okay, the number E is a non-recurring decimal, which is a 2.7182. Okay, observe the following. Okay, so the first one. Okay, log 10. Okay, log 10. This one means log base 10. Okay, log 10. Okay, so log 10 is very simple. This is 1. Okay, this is the first one. Second one, ln E. Okay, ln E means log EE. Okay, so also is 1. Okay, then the third one. Okay, the third one, ln E power x. Okay, this one you can drag the x in front. Okay, and then ln E. Okay, ln E at the second one, this is 1. Okay, therefore x times 1, you get x. Okay, this is for the third one. Okay, then the number 4 and number 5, you actually you can memorize these two, okay, and then it's a very useful. Okay, so how you get the number 4 and number 5? Okay, we see here. Where do I write? Okay, right here. Okay, we start with this. Okay, what is a log x? This one I can also write it as a ln x. Okay, therefore I using you know, the how to say, change the logarithmic form to index form. Okay, you use this log a n is equal to x, therefore n is equal to a to power x. You use this. Okay, so you see here the x I stay, okay, the e, okay, the base I move to this side become the base, and then the ln x become the power. Okay, now you see e ln x is what? Is x. E ln x is x. Okay, this is for number 4. Okay, but you must start with this, okay, log ex actually is ln x, okay. Okay, then for number 5, the same thing. Okay, you start with log 10x is log x. Okay, the right hand side, left hand side is the same thing. Okay, then you use this change to index form, so the x is there. Okay, the 10 move to this side, and then the log x, okay, move out as power. Okay, so 10 log x is x. Okay, 10 log x is x. So this is for number 5. Okay, they do questions have to use this number 4 and number 5. Okay, so this one may be. Okay, we try this. Okay, we try this. Okay, log 5 20 using common logarithms and natural logarithms. Okay, so it should have a same answer. It should have the same answer, even though you're using different logarithms. Okay, so first of all, okay, log 520. If I use a base 10, common logarithm will be LG 20 over LG 5. Okay, so we use a calculator, check and see. LG 20 divide by LG 5. Okay, so the answer is 1.861. 1.861. Okay, then if I use a ln, okay, so okay, ln 20 over ln 5. Okay, try and see. Ln 20 divided by ln 5. Okay, you get the same answer. Yeah. Okay, so that's all for that. So this is another example. Okay, given log 5x is p, express each of following in terms of the p. Okay, so you've got to adjust so that you can make use of this log 5x. Okay, you got to adjust so that you can make use of this log 5x. Okay, so you see now base is different. Okay, so I try to change to base 5. Okay, since a given one is in base 5. Okay, so I change to base 5. Okay, then this one go to the numerator, this one go to the denominator. Okay, so now log 5x, I can make use of this, so let it become p. Okay, then how about this log 525? Okay, you see log 525, you can write it as the 25 is 5 to power 2, the 2 you drag in 5. Okay, then log 55 is 1, so 2 times 1 you get 2. Okay, this is how you get the answer p over 2. Okay, the other example. Okay, log x, same thing. Okay, I'm going to change it become a log 5. Okay, so this is because of this given one is 5. Okay, so log 5. Okay, so this one will go to the numerator. This one will go to the denominator. Okay, then log 5x is given as p. You can replace it with p already. Okay, then this one you got to do some more. Okay, this one in between is a times. So break it into two logs. Still a log base 5, log base 5. Okay, so become plus. Okay, the 25 write it as a 5 to power 2, and then the power 2 drag it in front. Okay, this one power 3 drag it in front. Okay, next log 5x is given here as p. Okay, so this is 3p. Log 5 as 1, so 2 times 1 is 2. Okay, this is the final answer. So this is another homework. Okay, now it's 803. Yeah. Okay, look at this. Okay, problem involving indices such as 3 to power x equals 70 that cannot be expressed in the form of a to power x equal to a to power y, or a to power x equals to b to power x can be solved by using logarithms. Okay, this one, you still remember when we start this subtopic? Okay, we go back to the page 109. Okay, this when we start this subtopic, you still remember this part? Okay, that we say we can't solve it. Okay, we cannot, because we cannot write in this way. Okay, if you can write in this way, then by using the index law, then we can solve it. But we cannot write in that way. So we have to use our logarithms to solve this kind of problem. Okay, so I go back to just now. To solve this, 3 to power x is equal to 70. Okay, before we see into this example 32. Okay, how we going to solve this? Okay, because the 70 you can't write it as 3 to power of something. Okay, if you can write it as 3 to power something, then it's easy lah. You can use this. Okay, once the base is the same, you can compare the index now. Okay, so what you can do to this by using a logarithm is you log both sides. Okay, you can choose to use a base 10 or base e lah. But normally we will choose to use base 10. Base e is if the question asks you to use, then only you will use lah normally. Okay, so I choose to use base 10. Okay, so log it both sides. This one we call it log it both sides. It seems like, square it both sides, square root it both sides. Okay, same thing. Okay, so this is log it log both sides. Okay, means left hand side you put a log, right hand side also you put a log. Because you do anything to the one side, you got to do the same thing to the other side. Okay, so now it become log 3 to power x equals to log 70. Then the power here you can drag in front, so it becomes x times log 3 equals to log 70. Okay, next step here is times. So log 3 can move to the right hand side, become dy. So x stay here, log 70, log 3. This is how you get the answer for x. Then here, this part, you just press calculator. Log 70 divided by log 3. Okay, so we look at the example 32. Okay, if I'm too fast, anything that you don't understand, you have to stop me. Okay, then I will repeat. Okay, if you don't stop me, then I will just, like to train, okay, go non-stop. Okay, look at example 32. Solve the equations. Okay, this one do the same thing.
Teacher.
Yeah.
Do we write log or lg?
You mean log?
Yeah, lg or lg.
Log, lg, we understand both are base 10.
So it doesn't matter.
Mm-hmm.
Okay, thank
Doesn't
you.
matter. But if other base, you got to write the base. Only the base 10 is spatial. You don't have to write the base. Okay, so we continue. So you see example 32, it seems like this example. Okay, so first of all, you log in both sides. Okay, and then drag the power come down. Drag the power come down. Okay, so this is what you get. Okay, next. This one is a more complicated. Okay, because here you got x, here also you got x. So what you go next you're going to do is you expand it. You expand it. Okay, so x, okay, times log 3 minus 4 log 3, and then right hand side x times log 50 minus 3 times log 50. Okay, so you group the one with the x. So this term you move to this side, and then this term you move to the right hand side. Okay, so this one positive become negative, this one negative become positive. Okay, next factor out the x. Okay, factor out the x. Okay, then here is log 3 minus log 50. This one do nothing. Okay, last step already. This one is times with the x, so move to this side, become divide. Okay, one shot, this whole thing, press calculator. Okay, be careful. This one you got to put a bracket for this. When you press calculator, because it's divide by this whole thing. Okay, if play safe lah. This one also you put a bracket. Okay, if you want to one shot, press calculator. Okay, this one I leave it to you lah. Example of 33. Okay, now we come on. Okay, solve the following natural logarithmic equations. Okay, ln stand for log e. Okay, you can change it to a log e. Okay, then when come to this step, okay, this one you can change it into index form. Okay, so 4x minus 2 stay. Okay, the e come to this side become the base, and then 5 move out become the power. So e to power 5 is equal to 4x minus 2. Okay, so next 4x stay. Okay, remember e to power 5, you can just press calculator afterwards. Okay, this one plus 2. Okay, and then last step, e to power 5 plus 2. Sorry, power 5. Okay, this one times 4, so divide by 4. Okay, let us see. Okay, e to power 5 is here. Okay, shift long. Okay, e to, and then up to, okay, plus 2. Okay, call out the answer first before you divide 4. You know, you got to put a bracket for the whole thing. Okay, this is how you get the answer. Okay, look at B. Okay, B, I think the first step, I'm going to move the 10 to this side. So 335 divide by 10 first, so I get the 3.5. So e to power of 2x is 3.5. Okay, and then you can put ln for both sides. Okay, put ln for both sides. Okay, put ln for both sides means what? Log base e. Okay, 2x I write in front. Okay, log e 3.5. Okay, this one log e is 1. Okay, therefore 2x is 3.5. Okay, so x is, this one you can write as ln 3.5 over 2. So it doesn't matter, sometimes you write no ln, sometimes you write log e, it's the same thing. Okay, so you just press calculator to get the answer. Okay, ln 3.5. Okay, call the answer first, divide by 2. Okay, so 0.6 to 626. Okay, I want you to put 3 significant figures. Sorry, 4 significant figures unless it's stated in the question. So like these questions 626 is not good enough. It should be 6263. But after the 3 is 8 so you got a plus 1. So it should be 6264. 6264. 4 significant figures. Yesterday also someone WhatsApp me asked me about this. Okay, if you see the answer at the at the back of the book, it only give you like 3 significant figures, don't care. Okay, it make it become a practice, a habit, you know. 4 significant figures with minimum 2 decimal places. Like this one, 1, 2, 3, 4, 5. This is already 5 significant figures. Okay, it's good enough. More than is okay, but don't want less than. Okay, like this one is only 3 significant figures. Don't want. Okay, I want 4 at least. Okay, like this one, 1, 2, 3, 4. This is 4 significant figures. Okay, you all wait for a while. Okay, you all go through this example 34. Okay, look at the question first. D. Okay, sorry. Okay, come back here. Okay, look at example 34. Okay, the temperature of a block of a steel rises from 30 degree to T degree when it was heated for X seconds. Okay, X is the time. Okay, and then the T is the temperature. Okay, so given in this formula, T equals to 30 and then in bracket times 1.2 power X. Okay, that means the temperature of the steel, okay, when it is heated for 10.4 seconds. Okay, so this 10.4 is the X. Okay, find the determine the temperature, so means find the T. Okay, so we can straight away go through 10.4. This is the answer. Okay, so we just apply the formula, very simple. Okay, so the X is a 10.4. Okay, so press calculator to get the T. Okay, make sure you know how to press calculator. Okay, let us see. Okay, 1.2 power 10.4. 1.2 power. I think this one, power. Okay, 10.4. Okay, then answer, then times with 30. Okay, so this is the answer. Okay, same thing, this is a 4 significance, but I want minimum 2 decimal places. So this one should be 80 lah. Okay, if you want this one, it should be 80. Okay, 199.80, 2 decimal places. Yeah. Okay, now we look at B. Okay, the time X in a second taken to increase the temperature of the block of steel from 30 to 1500. Okay, so the 1500 is the T. Okay, then they are asking for an X. Okay, so we come back here. We still use the same formula. Okay, now the T we specify 1500. Okay, and then we want to find the X. Okay, so first of all, the 30 move to this side. Okay, divide first. So 1500 divided by 30 is 50. Okay, when come to here, okay, same like just now, you got to log both sides because the 50 you cannot write it as a 1.2 to power or something. So log both sides. Okay, log 50 is equal to log 1.2, the X drag in front. Okay, then log 1.2 move to this side, become divide. Okay, just press calculator to get the answer. Okay, the X is the second, so 21.4567 seconds. Okay, actually 4 significant figures, this is good enough. Okay, and then remember this one got the plus 1. Okay, so you can write 21.46 seconds. Okay, with minimum 2 decimal places. Okay, finish, huh? Okay. So you have a weekend, I give you more work lah. Okay, this one as a homework. Okay, this one no need to do, or you can copy if you want. Okay, this one I'll explain to you. I will do for you. Okay. And 4, 5, 6 you can do. This one also, this one also. This chapter you must do more. You must do a lot. This chapter, a lot of students cannot cope. Okay, so this chapter you must always. I will do one more questions for you. Okay, here question number 3. Then you go to the questions. Okay, the price of a house after n years. Okay, so this n is referring to the number of years. Okay, it's given by this equations or formula. Determine the minimum number of years. Minimum number of years. Okay, for the price of the house to exceed 300,000 for the first time. Okay, we don't care about this minimum number of years first. Okay, we put this into inequality. Okay, exceed 300,000. Okay, so means this. Okay, the formula. Exceed means more than 300,000. Okay, we do first, then after that we analyze from there what is the minimum and the n should be. Okay, so first step I'm going to do is these 3 0 3 0 can cut, one more 0 can cut. Okay, so the 26 move to this side become divide. Okay, so it's a 30 over 26. Okay, then after that you can log both sides. Okay, same thing, because even though this is an inequality or equations, the same thing, because 30 over 26 you cannot write it as a 9 over 8 to power or something lah. Okay, so you got to log it both sides. Okay, so log 9 over 8. Okay, and then the power you drag in front. Okay, log. Okay, this one can simplify, divide by 2, so 15 over 13. Okay, this is the next step. Okay, after that, okay, when you want to move the log 9 over 8 to the right hand side to divide, this one I want you to pay attention. Okay, always check this, whatever you want to move to the other side, okay, is positive, because this is inequality. You got to make sure the sign. Okay, if this is a negative, then when you move to the other side, you remember to change the direction of the inequality. Okay, so now, okay, press calculator first, get the log 9 over 8. Okay, see whether it's positive or negative. Okay, log over 8. Is it correct? Correct. I'm still not sure. Okay, one more time. Why the answer straight away cut out? I want to cross bracket. Cross bracket. Okay, correct. Okay, so this is a positive. Okay, so if positive, you move to the other side, then doesn't matter. So don't, no need to change the sign of the inequality. So 15 over. Okay, divide by log 9 over 8. Okay. then I find the answer. Okay, this is the 908. Okay, now I find log 15 over 13. 15 over 13. Okay. Divide by just now my answer. Okay, equals. Okay, so my answer is 1.22. 4 significant figures. So 214, but this is 9 plus 1, so 215. Okay, 215, 4 significant figures. Okay, but this is not the answer yet. Okay, because the number of year, the number of year we cannot have a 1.215, and then some more this is an inequality. So you got to make the final conclusions. Okay, that means the minimum number of year. Okay, so your n must be an integer and must be greater or bigger than 1.215. Okay, so bigger than 1.215 cannot be 1 lor. Okay, you start with 2 lor. Okay, so your n can be 2 lah, 3 lah, 4 lah. Okay, all this is bigger than 1.215. Okay, but they want the minimum number of year. Minimum means the smallest one, so the n is 2 lor. Okay, therefore you write n is 2. Okay, or the minimum number of year is 2. Okay, so this is a final conclusion. Okay, must make the final conclusion. Okay, if not, then the last mark you cannot get for this type of questions. Okay, that's all for today. Okay, any questions to ask? Okay, Yenny can stop recording.